So to cover the essential things, so this is, as I captioned here, the dry but important parts that we have to know. So when we talk about coding, we have to describe the data. And the data and things in the code's interpreting might have different forms. So we talk about these in types. So an integer is a number, it's a whole number, so not a decimal number. And it could be something like the bit depth of your image, your intensity value. If you take an area image, area selection, it might be an average, so it might have a decimal, so that wouldn't be an integer. You can have signed integers, so that's like negative values or positive values, and they're all still whole numbers. If you do need decimal points, so things like a calculation answer, that's called a float. And so we can see here that it can be negative or positive, and it can have decimal places. And usually we would stipulate somewhere else in the program how many decimal places to calculate it to. We have these things called Booleans. So that's your true or false, which is 1 or 0 as well. So yeah, true or false statements, they can be determining should something run or not. You know, if I have an image open and it has 3 channels, then do something. If it only has 2 channels, do something else. If it has 1 channel, put up a message saying, hey, it's only got 1 channel. So, you know, we can use these and stack a lot of these things together to direct our code automatically. So you could have characters, they're 1 letter, and everything in coding here is case sensitive. So uppercase A is different from lowercase a. And a character is kind of building up a word, and a string is multiple characters. So basically it's an array or a table of letters. A word is in coding space is like a table of letters. So they're the main types, right? So you have whole numbers, signed numbers, decimal place, true or false, and then kind of words. And so a variable in Fiji is a container that we use to access or, you know, hold information that we can then access elsewhere in the program. So it might be something that holds data. It could be referred to by name. So you could say like number of nuclei is 5. So the variable is number of nuclei, and it's got the number or the integer 5 stored in it. It'll be written, it will be written over if you reuse that variable. So if you had it as like the variable's my file name and you're opening images, you want that to override itself every time it opens the image, because you can't code every single image combination. So you could say, open the image, what's the file name? Okay, now I just need to always refer back to this thing variable called file name. Variables work for every data type, right? So it could be an integer, it could be a string, it could be a number, it could be a word. So good practice is to kind of make a new variable as you need one. Don't call like a single variable temp, because what can happen is if at one point temp is referring to the size of your median radius, and then all of a sudden you start giving it a file name, it's going to crash your code, because as we learn later, you have to kind of stick to the same type, otherwise you'll break things. And yeah, so that's what the bad is. The don't change the data type via assignment. So don't override a string with a number or a number with a string, because that's going to break stuff. So how do you name variables? You can, you know, as I said, they're case sensitive. You can call them whatever you want, but you can call it whatever you want. A good thing is this table where we give it, where we kind of start with F because that's a float, and start with I if it's an integer, and S if it's a string, you know, A or something for array, or an index. That kind of is a nice thing to do, so that future you, when you're trying to figure out why something's not working, you can quickly see, oh, that should be a number, and I'm handing it something called S, which is a string. They all have to be one kind of word. There's no spaces, is we put like camel case, where we go like, you know, capital letter beginning every word, so that you can read it a bit easier. There's technically no limit to how long it can be, but I wouldn't go writing a massive long story in each name. There are certain things that you can't call it. So there's like these protected words like run and print and for, because they're used elsewhere. So you can't overwrite and name those type of things. And yeah, as the last bullet point says, these are kind of the old school type where you would declare the type. So, you know, as I said, be clear about the purpose of them. Don't call it temp, call it number of nuclei or something like that, because the other person is going to read your code, which is likely going to be you again in the future. It makes your life easier. So once you've determined what you're going to call the word or the variable, you're going to need some kind of operation, which is, in this case, let's talk about equals. So what we can do in Fiji is on the left side, we'd call it something. So num, you know, I num nucleus. You've got to guess as to what that might be doing. Number of nucleus, exactly. Or, you know, S my folder might be a string to the location of your folder of images. So we would say like, no, I num nucleus equals, because we're then going to assign some variable to that variable, some value to that variable. So in the case of the right side, you might have 100, that's an integer, or, you know, the folder name or some float. And so that's what it would look like. I num nucleus equals 100. You've just set that variable to hold the value 100. And we can do things so with variables and numbers and coding. So we can, you know, use the common stuff. So because they're probably going to be dealing with numbers, you might want to add the numbers together, subtract numbers from each other, do these things, multiply them, divide, whatever. So in the case of numbers, if you want to say like score 1 equals 3 and the second score is 5, the total would be just score 1 plus score 2. And then we can print this thing called total score, and it says 8. Hooray. That makes sense to everyone, I hope. Cool, seeing nodding. But you can also do addition on like a string. So here we've got like the file name equals control image, and then I might want to do something to it, like flatten it, max project it, crop it, something, and then save it out. So I want to add onto the end, or append, or concatenate is the word, output to the end of this. So we can say the output file name equals input file name plus our output suffix, and then we print that, and that's what we get. Does that make sense? Really, strings only work with adding. You can't divide two words. It's not going to work. Then we have these things called arrays. And arrays are just going to tables to hold variables. But we have to think of them more in like one dimension, so like one column of data. So in this case, probably shouldn't come up. All of it should come up. So arrays are lists. Arrays and lists are interchangeable. Sometimes we call it a list, sometimes we call it array. Some of the commands are the list commands, but it's the same thing. We denote an array by these square braces or square brackets. And items are separated by a comma. So here, if I say, how do you make the first two columns into arrays? So this column here, I've just put a confocal 1 in inverted commas, and then the next one, so comma, slide image of 2, and then comma. And so each of these with these inverted commas are holding a string. And then we have the second one, which follows the same pattern of the vendor. So we can call elements of these or find the index of the array. And they start at base 0 is what we call. So this would be 0, this would be 1, 2. So we'll cover this in the next bit. So how do you actually call the information in the array? So we can query them by their index, so that number. And we can also do like whole statistics on arrays. So if you've got a big array with like the average intensity of every cell, you could just say, what's the average of that array? And it would then return it to you. You can ask it what's the maximum value or the minimum value, all standard stuff. So what we might say is, if the array for this was called name, so the first event of name is live imager 2. The reason it's that is because the confocal 1 name is actually the 0 position in the array. So it starts at 0. So 0, 1, 2, 3, right? And so room 2 for the array would actually be this one. It's the third value, but it's the second index of the array. So that usually trips up a few people. Does that make sense? Cool. And so if you wanted to know everything about this one, the Zeiss live imager 2, you would say like system name equals name of 1, which would then resolve to that, right? And then like the system vendor would resolve to that. Now I've been naughty and not called them I and S and things like that. But so here, this is the name is the array on the table, but then system name, we could have a variable called that would populate with this, right?